Okay. So in our last class, we discussed about synthesis of vitamin B1 and riboflavin, vitamin B2. And today we will take up vitamin B3. Okay, vitamin B3 is also called as pantothenic acid. This pantothenic acid is belongs to the water soluble one. 1 minute, I will give an entry to your friend. Okay. Ah, vitamin B3 is also called as pantothenic acid, and it's a water soluble one. So if you are looking into the source, it is present in liver. Okay. Uh, I think you are aware about liver. Okay. Then dairy products. Okay. That means pantothenic acid or vitamin B3. It is also found in dairy products. It is also found in eggs. Okay. And then it is also present in cereal, bran, leaf vegetables, and crude cane molasses. And if we are looking into the deficiency diseases, it's a deficiency not known in man due to widespread of this vitamin B3. Right. And this will be the structure of pantothenic acid or vitamin B3. So what you can observe. So what I am asking now. So can you tell me how many chiral carbon atoms are present in this pantothenic acid? So try to find the chiral carbon atom. Okay, that means a four different groups are attached to the same carbon atoms. That you have to find it out. And tell me how many chiral carbon atoms are there in this pentatonic acid.
Single source, one only one.
Okay, very good. Only one, only it's there. More particularly, this one. Okay, this is the chiral carbon atom. This is not the chiral carbon atom. It's a gem methyl group. Okay, right. Okay, and okay, this is the pentatonic acid. So with this, I will go to the next slide. So next slide will give you the information about synthesis of pentatonic acid. So how one can synthesize pentatonic acid? Uh, Here you can observe that this is a lactone. So why it is called lactone? Because what is called as ester group is in cyclic form. If the ester is in cyclic form, then that compound is called lactone. So this lactone, when it is treated with a compound, so what is the name of this compound? I think you are aware about the alpha amino acids. So this is the functional group called ester functional group. Adjacent to this ester, this position is called alpha, and this position is called beta. So beta, there is a amino group is there. So that is the reason beta amino ethyl ester. So this is ethyl. And I think you know that alanine. What is the structure of alanine? CH3, CH, COOH, and NH2 is called alanine. So alanine is the alpha amino acid. So whereas this one is beta amino, okay, and it's an ester. So what we can say that ethyl beta amino alanine ester. So what will happen here? The important thing, the lone pair present on this nitrogen attack this carbonyl carbon, and this picks up a proton. So that is how a compound is obtained. And here you need to change this particular CH2 as a CO. Okay, I will change it now itself. This is O. Okay. Now I will go back. Okay. So this is O. Okay. So when it is O means then only this a compound. So that means there will be a new bond formation between this nitrogen and this CO group. Okay. So that means from here to here CO, this one. And the remaining OH is this is a chiral carbon atom, this one. And adjacent to this, two dimethyl group. These are two dimethyl group, and then CH2OH, CH2OH. So this is how the compound is obtained. And here, this an ester means pentothenic ester, ethyl ester, when it is treated with barium hydroxide. It's a mild hydrolyzing agent. It converts ester into acid. So that is how a pentothenic acid is obtained. It's a simple two-step reaction. First step is condensation, nucleophilic substitution reaction, and the second step is hydrolysis. So you can find a different steps. Maybe what you can do, the organic chemistry by IL Finer. Okay, in that you can find uh, uh, more information on vitamins. Okay, so with this, I will go to the next slide. So next slide will give you information about biological importance of pentothenic acid or vitamin B3. So what is the biological importance? I think you know that a coenzyme called coenzyme A. Okay, coenzyme A is represented as COASH. COASH is called coenzyme A. And here I'm written the structure of coenzyme here. So what you can observe here, you can, so you know that this is the ribose group and this is a adenosine group, adenosine ribose, and this is a phosphorus moiety is attached means then it is called a nucleotide, adenosyl diphosphate. This is called adenosyl diphosphate. And from here, okay, this O, CH2, C, CH3, CH3, CHOH, CO, okay, up to this, okay, is called what is called as pentothenic acid. That means what it means, pentothenic acid is it is present in a coenzyme A. Okay, so coenzyme A is required by the enzymes that catalyzes the transfer of acetyl group. Okay, so that means this one will act as a transfer of acetyl group to the substrate. So that may be more particularly what we can say that occupies a central role in a number of metabolic processes such as acetylation of amines, acetylation of alcohols, and other condensation reactions also. So these are all what is happening in the living system. So pentothenic acid is thus essential for the biochemical reactions involving two carbon acetate unit like so this uh, also involve in the biosynthesis of adrenocorticohormones. So these adrenocorticohormones are very much required for the lubrication. Okay, lubrication purpose. More particularly, maybe after certain age, people used to say that the knee pain, joint pain. That knee joint pain, it's because of the adrenocortico hormones functioning. If the adrenocorticohormone functioning is less or not efficient, then joint pains occurs at the older age. So that's because of the function of adrenocorticohormones. That what it means? It means that vitamin A is the precursor to the coenzyme A coenzyme A, and this coenzyme A is required by the enzymes that catalyzes the acetylation of amines, acetylation of alcohol, and other condensation reaction. And this coenzyme is also involved in the biosynthesis of adrenocorticohormones, and it is also involved in the biosynthesis of cholesterol. Again, cholesterol is also another naturally occurring compound in all living beings. Okay. Right. Anyway, you will come to know more about cholesterol. One chapter, full chapter, 13-hour chapter, when you are in fourth semester. And also biosynthesis of fats. Okay, fats. Okay, I think you know that what is fat. Fat is a naturally occurring uh, maybe 14 carbon and high. Okay, carboxylic acid. Okay, that means long chain fatty acids. Right. So this is about the biological importance of vitamin B3. So what you can say that pantothenic acid is the precursor of coenzyme A. Coenzyme A is the one is required for the enzyme that catalyzes the transfer of two carbon unit to the substrate, like acetylation of amines, acetylation of alcohols, and other condensation reactions. So pantothenic acid is thus the essential for the biochemical reactions involving the two carbon acetate unit, like the biosynthesis of adrenocorticohormones, cholesterol, fat, etc. So this is about you may need not to be write the structure of coenzyme A, but these are the points you need to remember, and these are the points you need to write if there is a question on biological importance of pantothenic acid. This is about the pantothenic acid. So what we are discussing about the vitamin and their sources and their deficiency and their synthesis and their biological importance. So with this, I will go to if you feel that there is no doubt in pantothenic acid, I will go for a next. I will take up next vitamin. Do you have any doubt in pantothenic acid? Otherwise, vitamin B3. So if it is no means, I will go for a next vitamin that is called vitamin B3. Right. What I will take up next vitamin called vitamin B6. Okay, this is the one. So vitamin B6 is also called as pyridoxine. Okay, vitamin B6 is also called as pyridoxine. It is a water soluble one. So vitamin B6, it is present in yeast. It is also present in rice polisings. It's also present in cereals, grains, seeds, and eggs. So the deficiency effects of vitamin B6 is causes anemia. Okay, the deficiency effects of vitamin B6 is causes anemia. Severe deficiency can cause seizure and death. Okay, that means severe deficiency of vitamin B6 can cause seizure. I think you know that seizure is another disease. Okay, maybe you can. I think you should aware about this. Then death. This severe deficiency can cause seizure and death. And this vitamin B6, it refers to three compounds. One is pyridoxine, another one is pyridoxal, another one is pyridoxamine. So just there is a changes in the functional group. You can observe that OHCH3, and this moiety is called pyridine. Okay, so when pyridine is having a different functional groups, you can observe that OHCH3. This OHCH3 is commonly present in all pyridoxal and pyridoxamine also. But what is the changes? You can observe that these two groups, CH2OH group, if there is a two CH2OH, one OH and one CH3 to the pyridine is called pyridoxine. And suppose this CH2OH, fourth position CH2OH is converted into CHO, then it is called pyridoxal. Okay, you just remember this pyridoxal. Why? Because when I am talking about the biological importance, I will use the word called pyridoxal pyrophosphate. Okay, PLP. And then uh, if this CHO is reduced, okay, then CH2OH, then that is called pyridoxamine. So you just look into that. This is pyridoxamine. So more particularly, 4th hydroxy CH2OH is oxidized, then it is called pyridoxal. And this pyridoxal, when it is reduced, is called pyridoxamine. So all these three uh, components is required, and these three combinedly it's called as vitamin B6. Okay, sometimes vitamin B6 means all these three. Then with this I will go for a synthesis, how one can synthesize pyridoxine and how the pyridoxine is converted into pyridoxal and pyridoxamine. So that we will discuss, okay, in a next slides. So with this I will go for a next one. So here I am explaining about how one can synthesize pyridoxine. So if you want to go for this, just look into the reactant or raw material. So this is one reactant or raw material. This is another reactant or raw material. So I will start with this. So this is CH3CO is called acetyl group. CH2CN is another CH2CN means acetonitrile. So then what we can say that if you want to name this particular one, cyano is there, no? You can start with this cyano. Okay. Okay. So one small changes. This is not a CH3. This should be NH2. So I will change it now itself. So this is okay. So this is NH2. So with this, I will go back. Okay. So this is NH2. So if you want to name this, here this will be the cyano, and this group is called acetamide. So cyanoacetamide is one reactant. Another one, how you can start? You can start with this ethoxy group. This is ethoxy, and these two carbon atoms CH2CO is called acetyl, and CH2CO CH3 is called acetone. So what is the name of this compound? Ethoxy acetyl acetone. Ethoxy acetyl acetone is the another reactant. So that means when cyanoacetamide is treated with 1,3-dicarbonyl compound called, this is 1,3-dicarbonyl compound, 1, 2, 3. So in general, more particularly, it is called ethoxy acetyl acetone. So cyanoacetamide, when it is treated with ethoxy acetyl acetone, on condensation, removal of water, giving rise to intermediate like this. So what I will, I think you know that dicarbonyl compound, they will be in equilibrium with the enol form. So that means one of the proton from here moves from this carbon to this oxygen. Then there is a formation of double bond here, and there is a single bond formation, and there is a OH bond formation. So that is called enol form. So enol form or a keto form can react with this. What is H2 and O will go out. Similarly, this H2 and O will go out. So a cyclized product is obtained, and from here to here, movement of this proton from here, nitrogen to oxygen, and there will be a formation of double bond, and this is called amide enol tautomerism. So from here to here, it's an amide enol tautomerism. And maybe what I will explain from here to here. So you can observe that ethoxy group is here, this CH2 group is here, this CO group is this one, and this CH2 is converted into CH, and this carbon is this, CH3 is this, and the remaining part, this NH2 is this, CO is here, and CH, now it is C because forms a double bond, and Cn, this is Cn. So this is about how you can, maybe what I can say that this part is called cyanoacetamide part, and remaining part is called ethoxyacetyl acetone part. And from here to here, it's about only the amide enol tautomerism. That means the proton present on nitrogen moves from here to this oxygen. There will be a formation of double bond, and there will be a formation of single bond. There will be a OH bond formation. This is what obtained. So from here, so from this step to this step, it is a reaction of HNO2, HNO3. So HNO3 means it's an what is called as a nitrating agent. So it will act as a source of nitronium ion, means NO2 plus. So that means you know that this particular position only empty, because all other positions are occupied by the substituent. So this one is gets nitrated. So the obtained nitro compound, when it is treated with a chlorinating agent, so you know that chlorinating agent means it will convert this hydroxy group into Cl. Okay, this hydroxy is converted into Cl by halogenating agent called phosphorus pentachloride. Then afterwards, what will happen? So this one, when it is treated with hydrogenation in presence of catalyst. Okay, so hydrogenation in presence of catalyst. So here this supplies hydrogen. Okay, so hydrogen to the nitrile. Nitrile, you know, no, C triple bond N. C triple bond N is gets converted into CH2N2. That means reduction of nitrile give amines. Okay, and similarly, you can observe that there is a nitro group. This nitro also on reduction gives amine. Okay, that means two things is happening here, two, not two, three things is happening. So one is nitrile is converted into amine, nitro group is converted into amine, and this chlorine also going out. So that means hydrogen is added to this carbon. So that is how the product is obtained. Okay, so now at this stage, this one subjected to diazotization. You know that diazotization. So diazotization means conversion of a amine into diazonium chloride. So the obtained diazonium chloride, when it is treated with boric acid or ethanol, so N2Cl is replaced with OH. Okay, so that is how amine is converted into hydroxy, means water source. Diazonium chloride, when it is treated with water source, it will give an alcohol. So conversion of amine to diazonium chloride is converted into OH. So this is about the conversion from this step to this step. So at this stage, you know that this bond is called ether bond. That ether bond can be cleaved. The bond between the O and C2H5 can be cleaved by treating with hydroxybromide. So it's known as ether cleavage reagent. So here there will be a living group C2H5Br will go out. Then what is the forming? The formed one is OH here, OH here, Br here. Okay, means OH come initially. That OH again react with Br and converted into bromide. Similarly, this OH also react with Br converted into bromide. I think you know the difference between the alcohol and phenols, isn't it? So this is an alcohol. Okay, so that is the reason alcohol is gets converted into bromide. But this OH is not an alcohol; it's a phenol. Okay, conversion of this OH to bromide is difficult. Okay, that you should aware. So phenol is different, alcohol is different. Alcohol can be replaced with hallucinating agent, but phenol replacement is difficult. Okay, hydroxy group of which is attached to the benzene is called phenol. So that's replacement is difficult because this is the aromatic nature one. So from here to here, what will happen? That's what I explained, HBr, right? So from here to here, replacement of this Br with hydroxy group, that is possible by treating water in presence of silver chloride. So treatment of water in presence of silver chloride replaces the Br with OH. So that is how a pyridoxine is obtained. So how many steps are involved? You can look into that. This is one, this is two, three, four, five, six, 7 steps are involved. Okay. So, but what you need to remember, you can just remember these two reagent and remaining thing you should write automatically, and you have to remember this product. So remember product and the reactants. So remaining thing you have to write. And such a way that you need to practice for the synthesis part. So this is maybe I will explain once again. A condensation reaction is involved. From here to here, ketoenol tautomerism, amide enol tautomerism. From here to here, it's a nitration. This position is nitrated. From here to here is a halogenation. This OH group is replaced by Cl, and from here to here is a reduction. So Cn is get converted into CH2NH2, and NO2 is gets converted into NH2, and Cl is replaced with hydrocarbon, conversion of aryl halide to aryl compounds, arene compounds. And from here to here, it's a conversion of NH2 to diazotization, and then diazotization and reaction with water gives rise to alcohol, phenols. So from here to here, it's a cleavage of ether linkage. Ether linkage cleavage converting into OH. The obtained OH react with bromine forms a bromide. This OH also converted into bromide. This is not because it is a phenol one. And what is the conversion from conversion of this to here? Both the OH is converted into Br. So Br is replaced with OH. So that is what here. So this is about the synthesis of pyridoxine. So now I will go to the next slide. So next slide I will explain about the what is called transformations. So transformations means how the pyridoxine is gets interconverted into pyridoxal, and how pyridoxal is converted into pyridoxamine. How the pyridoxamine it gets back into the pyridoxine. So that interconversion I will explain in the next slide. So this is the one. Okay, interconversion of pyridoxine to pyridoxamine. Right. So this is the pyridoxine. So you know that this is one hydroxy, this is another, this is the aromatic one, this is another hydroxy. So here this 2 hydroxy, when it is treated with MnO2, MnO2 or KMnO1, MnO2. So both are oxidizing agents, manganese oxide and potassium permanganate. So what will happen? You know that this fourth position CH2OH is converted into CHO, and the obtained one is called pyridoxal. Okay, I think you know that this is an oxidizing agent. It converts a primary alcohol into aldehyde. So KMNO4. And the obtained aldehyde, when it is treated with hydroxylamine, so hydroxylamine, what will happen? There will be a removal of water. So H2 and O will go out as a water, forming an oxime. This is called oxime. So this oxime on reduction. So reduction means addition of H2 to the one H add to this carbon, another H add will add to this nitrogen, and OH will go out. So that is how a pyridoxamine is obtained. And this pyridoxamine, just by treating with the nitrous acid, how you will get nitrous acid? Nitrous acid means HNO2. How you will get the nitrous acid? Just by the combination of sodium nitrate and HCl gives the nitrous acid. So what is its role? Its role convert amine into diazonium chloride. So that diazonium chloride, when it is react with water, giving rise to alcohol. So this is about the interconversion. So normally they will ask questions on this also. So what they will give only the pyridoxine structure, and in the R mark they may write they may give reagent called KMNO4, and here there will be a question mark, and NH2OH, and here there will be a question mark, and hydrogenation means reduction, and here there will be a question mark. But you should know what is the product and how these are converted, interconverted. And maybe they can ask direct question, how do you convert a pyridoxine to pyridoxamine? So that is also possible, but there are questions on this slide. Okay, so from here to here it's oxidation, primary alcohol is gets oxidized. From here to here oxime preparation, this is called oxime preparation. How the oxime is prepared? By treating with hydroxylamine. This is hydroxyl, this is amine. So what is here? O and H2, H2O is going out, forming a CH double bond NOH. CH double bond NOH is called oxime. This oxime on reduction, reduction means addition of hydrogen. One nitrogen added to this carbon, another hydrogen added to this nitrogen, and this will go out. So that is how CH2OH, CH2NH2 is obtained. And this CH2NH can be, it is possible to convert into pyridoxine. Its process is called diazotization followed by hydrolysis. So this is about the interconversions. Okay, so with this, I will go for a what is called as biological importance. So biological importance means here I am talking about the PLP. So PLP means pyridoxal phosphate. So you know that what is pyridoxal? Okay, so this one is pyridoxal. So to this pyridoxal, you know that this is an hydroxy group. If this hydroxy group is phosphorylated, then the phosphorylated of pyridoxal is called pyridoxal phosphate. So in living system, pyridoxal is converted into a pyridoxal phosphate. The pyridoxal phosphate is the coenzyme required by the enzymes that catalyzes the amination, transamination. Okay. and then decarboxylation, and then of course you know that this is a decarboxylation, and from here to here what you can racemization. Okay, amino acid racemization. So what we can say that pyridoxal phosphate is the coenzyme required by the enzyme that catalyzes certain transformations of amino acid, that catalyzes certain transformations of amino acid. So there are several different kinds of amino acid transformations that PLP means pyridoxal pyrophosphate requiring enzymes catalyze. The most common ones are decarboxylation. So here this COOH present in a amino acid is decarboxylated. So this is catalyzed by PLP. So PLP is required the vitamin B6. Okay, uh, transamination. So that means you know that here NH2 is there. Okay, this NH2 can be moved from here to another amino acid. So transamination. So that means amine is added to another one. Okay, it's called transamination. Racemization. So racemization means conversion of plus one plus two plus or minus, or minus to plus or minus. That's called racemization. And what is called as C alpha C beta bond cleavage. You know that what is C alpha? This is the functional group, and this carbon is called alpha carbon. Okay, alpha bond cleavage, beta bond cleavage. Okay, uh, and alpha beta elimination. So alpha, this is the functional group. What is the alpha is there? Amino group is there. If this is eliminated, okay, and beta position elimination. So all these reactions is catalyzed by the PLP requiring enzymes. So for the PLP, the precursor is vitamin B6. And these are the examples I mentioned. So this is one amino acid. This amino acid, when it is treated with the PLP bound enzyme, so enzyme E by PLP andre PLP bound enzyme. So what is going out? Amino decarboxylation. CO2 is going out, and this process is called decarboxylation. So what we can say that decarboxylation of amino acid in presence of enzyme bound PLP gives uh, decarboxylated and a product byproduct. So similarly, here one more example I am taking. So this is an amino acid, and this amino acid, when it is treated with glutarate, more particularly ketoglutarate. So what is glutarate? Glutarate is nothing but a 5 carbon containing 2 carboxylic acid containing compound is called glutaric acid. Since it contains keto group, then it's called ketoglutarate. So this ketoglutarate, when it is treated with amino acid in presence of enzyme bound PLP, so what is happening? There will be a breakage. So what is breakage? Is it a breakage or a transamination? This amino group is moved from amino acid to here, keto group. So what is called as NH2 is comes over here. That means this oxygen is going over here. Okay, and then here this is an example of racemization, how the enzyme amino acid when it is react with the PLP bound enzyme racemizes. So you know that racemization, how the racemization occurs. Okay, you know that here what is called right. So I think what is required thing here in the product HH is there. That means we need to convert this CH3 into H. No, I will do it. So this you need to convert. You need to write it as a H. Okay. This is about the what is called as biological importance of vitamin B6. So now tell me, do you have any doubt in vitamin B6 and pentothenic acid, that is vitamin B3.
No, sir.
Okay, so maybe what I can do, let me stop at this stage, and the remaining thing I will continue in the next class. Okay, right.
Okay,
Maybe
sir.
maybe I you can log out now.